This video will teach you the basics of forces and how to solve problems regarding forces using free body diagrams. So what is a force? A force is the push or pull upon an object resulting from that object's interaction with another object. This means that if the forces are unopposed, they will change the motion of the object. So for example, imagine you push a box across the room. You are applying a force to that box, which is causing it to change in motion. There are four main types of forces that we'll go over in a minute, and every force acts in a specific direction that is situational to the problem. There's the gravitational force, which is the force that attracts any object with mass. So every object is pulling on every other object in the entire universe. This is known as Newton's universal law of gravitation. Gravitational force is commonly known as the force between the Earth and objects on the Earth. However, it can also be just the force between two objects that have mass. So gravity either points straight down towards the center of the Earth, if it's between an object and the Earth, or if it's between two objects, it will be in the direction of the opposing object. So, for example, a force between an object and the Earth is the most famous example of an apple falling from a tree. And this is due to the force of gravity pulling it downwards towards the center of the Earth. On the opposite side, the force between two objects, an example is that the moon is pulled towards the Earth due to gravitational force, and this is what keeps it in its constant rotation around our planet. Then we have the normal force. This is a support force exerted upon an object that is in contact with another stable object, and this is the force that prevents solid objects from passing through each other. And it is applied mutually in opposing directions of the two objects. So, for example, to help you understand, if a book is resting upon a surface, then the surface is exerting an upward force upon the book in order to support the weight of the book. But the book is also exerting an equivalent downward force onto the table. Then there's force friction, and this is the force exerted by a surface as an object moves across it. There are two types of friction force, which is sliding, also known as kinetic friction, and then there's static friction. So static friction is when an object is at rest, also known as it's not moving. So in that situation you have static friction. And sliding or kinetic friction is when the object is in motion. So friction most often opposes the motion of an object. So you know if it tells you that a book slides to the right, then friction will be towards the left. So, yeah. Then we have force tension. This is the force that is transmitted through a string, a rope, cable, or wire when it is pulled tight by forces acting from opposite ends of the rope or whatever. So the tension force pulls equally on the objects on the opposite ends of the wire. This is kind of hard to understand, but an example might help. So for example, a rope is hanging on a frictionless pulley, and there are boxes of equal mass on each end of that rope. So the rope is exerting force tension upwards on each of the box. Then there are free body diagrams, which are used when you need to solve a physics problem involving balanced forces. So these are used to show the relative magnitude and direction of all forces acting upon an object in a given situation. So let's go over one together. There is an object being pushed to the left across a room. Draw a free body diagram of the situation. First, we think about forced gravity. We know forced gravity always points downwards towards the center of the Earth, so we will draw an arrow pointing down from our box. Then we think about force normal. We know it will be equivalent to the force of gravity, but pointing up as the force is upwards from the floor, supporting the weight of the object. Then forced friction would point to the right, opposite the direction of the motion of the box being pushed to the left. Forced tension would not be included in this free body diagram because there's no rope or string or wire involved. Now we have some practice problems. A gymnast holding onto a bar is suspended motionless in midair. The bar is supported by 2 ropes that attach to the ceiling. Draw a free body diagram of the forces acting on the bar. The second problem is a book is at rest on top of a table. Draw a free body diagram of the forces acting on the bar. Book. Sorry. So I will give you some time for you to work on these, and I'll go over the solutions in a minute. Alright, if you're not done, just pause the video, but I'm going to go over the solutions now. So in the situation with the gymnast, we can think about forced gravity first. So as we know, forced gravity always points downwards towards the center of the earth. So we will draw a line of forced gravity pointing down. Then there's ropes involved, so we know there will be forced tension that needs to be included in our diagram. It says the bar is supported by 2 ropes that attach to the ceiling, which means the forced tension must pull upwards. It's pulling the bar upwards towards the ceiling, so we will draw 2 arrows pointing up. Friction will not be included in this diagram because the bar isn't sliding anywhere, and force normal will not be included because the bar is not on any surface that it would be trying to go through. In the second problem, there's a book at rest on top of a table. Again, starting with forced gravity, always points downwards towards the center of the earth. So we will draw a line pointing down from our box. Then opposite of that is force normal. We know that because the book is at rest on top of a table, that force normal will push up on the book to ensure that the book does not fall through the table. This will be an equivalent length of line as forced gravity because the book is at rest, so the forces must be balanced. There will be no forced friction because the book is not moving, and there will be no forced tension because there's no rope or wire or string or anything like that. I hope this video helped. Thank you.